Welcome to Mind Map MCQ. This is part 1 of a 3-part series on weather. So prepare, practice and prevail. 1. What is atmospheric pressure? The options are A. The force exerted by the weight of water vapor in the air. B. The temperature at a specific altitude. C. The force exerted by the weight of air above a given point. D. The speed of wind in the atmosphere. The correct option is C. The force exerted by the weight of air above a given point. Atmospheric pressure is the force exerted by the weight of the air in the Earth's atmosphere on a surface. It is measured as the weight of the air above that surface in a column extending to the top of the atmosphere. Atmospheric pressure decreases with altitude because there is less air above to exert force. Standard atmospheric pressure at sea level is defined as 1013.25 millibars of mercury or 1 atmosphere. It influences weather patterns, boiling points of liquids, and respiratory functions. 2. Which instrument is used to measure atmospheric pressure? The options are A. Thermometer, B. Barometer, C. Anemometer, D. Hygrometer. The correct option is B. Barometer. The instrument used to measure atmospheric pressure is a barometer. There are two main types: the mercury barometer, which uses a column of mercury in a glass tube, and aneroid barometer, which uses a sealed flexible metal chamber. Both types measure atmospheric pressure by detecting changes in the air pressure which affects the height of the mercury column or the chamber's deformation respectively. 3. What effect does atmospheric pressure have on boiling point of water as we gain height? The options are A. Decreases it, B. Increases it, C. No effect, D. Fluctuates it. The correct option is A. Decreases it. As altitude increases, atmospheric pressure decreases, which in turn lowers the boiling point of water. This occurs because the reduced pressure at higher elevation means there is less force exerted on the water surface, allowing water molecules to escape into the vapor phase more easily. Consequently, water boils at temperatures lower than the standard 100 degrees Celsius at sea level. 4. Which layer of the atmosphere contains the highest atmospheric pressure? The options are A. Stratosphere, B. Mesosphere, C. Thermosphere, D. Troposphere. The correct option is D. Troposphere. The layer of the atmosphere that contains the highest atmospheric pressure is the troposphere. This layer extends from the Earth's surface up to about 10 to 15 kilometers at the poles and up to 17 to 18 kilometers at the equator. The pressure within the troposphere decreases with altitude, but at its lower boundary it can reach pressures around 1000 millibars, which is the standard atmospheric pressure at sea level. 5. In which unit is atmospheric pressure commonly measured in weather reports? The options are A. Millibars, B. Kilometers, C. Degrees Celsius, D. Joules. The correct option is A. Millibars. Atmospheric pressure is commonly measured in weather reports using the unit millibars. This unit represents the force exerted by the weight of the atmosphere per unit area of the Earth's surface. 6. Which factor does not influence the atmospheric pressure? The options are A. Altitude, B. Temperature, C. Humidity, D. Earth's rotation. The correct option is D. Earth's rotation. Altitude, temperature and humidity affect atmospheric pressure by influencing the density and composition of air. As altitude increases, air pressure decreases because there is less air above exerting downward force. Temperature impacts pressure through its effect on air density. Warmer air is less dense and exerts lower pressure. Humidity alters pressure slightly due to water vapor's lower molecular weight compared to dry air, but its impact is generally minor compared to temperature and altitude variation in atmospheric pressure dynamics. 7. Which term describes the horizontal distribution of atmospheric pressure? The options are A. Vertical profile, B. Iso height, C. Isobaric pattern, D. Isothermal map. The correct option is C. Isobaric pattern. An isobaric pattern refers to a map representation of atmospheric pressure where isobars or lines of equal pressure are drawn to illustrate the distribution of pressure over a specific area at a given altitude. These patterns help meteorologists identify high and low pressure system pressure gradients and predict wind speeds and directions. Closely spaced isobars indicate strong winds and a steep pressure gradient, while widely spaced isobars suggest lighter winds and a gentle pressure gradient. 8. Areas of high pressure are generally associated with. The options are A. Cloudy weather, B. Clear skies, C. Storms, D. High humidity. The correct option is B. Clear skies. Areas of high pressure are generally associated with clear skies. High pressure system typically indicates stable atmospheric conditions where air descends and spreads outward, inhibiting cloud formation and precipitation. This often results in clear weather and relatively calm conditions. 9. What are lines on a weather map that connect areas of equal atmospheric pressure? The options are A. Isotherm, B. Isobar, C. Isodrosotherm, D. Isoheight. The correct option is B. Isobar. Lines on a weather map that connect areas of equal atmospheric pressure are called isobars. These lines help meteorologists visualize and analyze pressure patterns across regions. Isobars are typically drawn at regular intervals, such as every 4 millibars, representing areas of uniform atmospheric pressure. 10. Low pressure systems are often associated with A. Descending air, B. Stable weather, C. Ascending air, D. High temperatures. The correct option is C. Ascending air. A low pressure system features a center with a lower atmospheric pressure than its surroundings. Winds converge towards this area, causing air to ascend. As the air rises, it cools and its water vapor condenses, forming clouds and often precipitation. 11. What is a pressure gradient? The options are A. A measure of atmospheric pressure at sea level, B. A measure of temperature differences, C. The average pressure over a large area, D. The rate of change of pressure between two places. The correct option is D. The rate of change of pressure between two places. A pressure gradient refers to the rate of change of atmospheric pressure over a given distance. It is calculated as the difference in the pressure divided by the distance between 2 points in the atmosphere. A steep pressure gradient indicates a rapid change in pressure over a short distance, leading to stronger winds as air moves from high pressure to low pressure areas. 12. Which factor causes variations in atmospheric pressure at Earth's surface? The options are A. Solar radiation, B. Latitude, C. Longitude, D. Earth's magnetic field. The correct option is A. Solar radiation. Solar radiation heats the Earth's surface unevenly, causing variations in atmospheric pressure. Regions receiving more intense sunlight warm up, causing the air above to expand and become less dense, creating areas of lower pressure. Conversely, areas receiving less sunlight remain cooler, leading to denser, higher pressure air. This temperature differential generates pressure gradients that drive atmospheric circulation and wind pattern globally. 13. In the northern hemisphere, which direction do high pressure systems rotate? The options are A. Counterclockwise, B. East to west, C. Clockwise, D. West to east. The correct option is C. Clockwise. In northern hemisphere, high pressure system generally rotate in a clockwise direction. This rotational pattern is due to the Coriolis effect, which deflects air moving towards the center of the high pressure area to the right. As a result, air circulates in a clockwise manner around high pressure systems in the northern hemisphere. 14. The intertropical convergence zone is characterized by. The options are A. High pressure, B. Stable air masses, C. Clear skies, D. Low pressure. The correct option is D. Low pressure. The Intertropical Convergence Zone, or ITCZ, is a belt of low pressure that encircles the Earth near the equator, where trade winds from the northern and southern hemispheres converge. It is characterized by ascending air currents leading to frequent thunderstorms and heavy rainfall. The ITTZ shifts its position seasonally, allowing the sun's zenithal position. This convergence zone plays a crucial role in global weather patterns, influencing tropical climates, monsoon systems, and the distribution of precipitation across regions near the equator. 15. What is the primary cause of the Coriolis effect? The options are A. The Earth's rotation, B. The Earth's magnetic field, C. The Earth's orbit around the Sun, D. The Earth's gravitational pull. The correct option is A. The Earth's rotation. The Coriolis effect is caused by the rotation of the Earth. As the Earth rotates, different points on its surface move at different velocities. This difference in velocity causes moving air and water to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere, creating the Coriolis effect. 16. How does Coriolis effect influence wind patterns? The options are A. It creates stronger winds near the equator, B. It causes winds to spiral around high and low pressure systems, C. It deflects winds to the left in the northern hemisphere, or D. It has no impact on wind patterns. The correct option is B. It causes winds to spiral around high and low pressure systems. The Coriolis effect influences wind patterns by causing winds to deflect due to the Earth's rotation. In northern hemisphere, winds are deflected to the right, while in the southern hemisphere they are deflected to the left. This deflection creates distinct wind patterns such as the trade winds, westerlies, and polar easterlies. It affects the direction of the cyclones and anticyclones, leading to clockwise rotation in the northern hemisphere and counterclockwise rotation in the southern hemisphere. This effect is crucial for understanding global weather systems. 17. Which statement accurately describes the Coriolis effect at the equator? The options are A. It has no effect at the equator, B. It is the strongest at the equator, C. It causes air to move directly north or south, D. It reverses direction at the equator. The correct option is A. It has no effect at the equator. At the equator, Coriolis effect is essentially non-existent. The Coriolis effect is zero at the equator because the Earth's rotation does not cause any lateral deflection there. Moving air crosses the equator without being deflected to either side. As a result, winds and ocean currents experience no Coriolis-induced turning. 18. Which factor does not affect the magnitude of the Coriolis effect? A. Wind speed, B. Latitude, C. Altitude, D. The Earth's rotation speed. The correct option is C. Altitude. The Coriolis effect is a result of the Earth's uniform rotation. Regardless of altitude, the rotational speed of the Earth at a given latitude remains constant. Therefore, an air parcel or any moving object will experience the same Coriolis force at a given latitude irrespective of its height above the ground. 19. What is the primary reason the Coriolis effect is stronger at higher latitudes? The options are A. Higher temperatures, B. The curvature of the Earth's surface, C. Increased atmospheric pressure, D. Greater rotational velocity. The correct option is B. The curvature of the Earth's surface. The primary reason the Coriolis effect is stronger at higher latitudes is due to the Earth's rotation causing a greater rotational velocity differential as one moves away from the equator. At higher latitudes, the Earth's surface travels at a slower speed compared to the equator, resulting in a more pronounced deflection of moving objects. This effect is maximized at the poles where the rotational influence is greatest and non-existent at the equator where there is no latitudinal change in rotational velocity. 20. How does the Coriolis effect influence global wind patterns? The options are A. It causes wind patterns to be chaotic and unpredictable. B. It eliminates differences in wind speed. C. It only affects winds over the ocean. D. It helps establish the wind belts, trade winds, westerlies and polar easterlies. The correct option is D. It helps establish the wind belts, trade winds, westerlies and polar easterlies. The Coriolis effect influences global wind patterns by causing moving air to deflect to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection shapes prevailing wind belts such as the trade winds, westerlies and polar easterlies. It helps create large-scale wind patterns like the jet stream and cyclonic systems, contributing to the overall circulation of the atmosphere and impacting weather patterns, ocean currents and climate systems worldwide. 21. What is the primary driver of the general circulation of the atmosphere? A. Ocean currents. B. Earth's rotation. C. Differential heating of the Earth's surface. D. The greenhouse effect. The correct option is C. Differential heating of the Earth's surface. The primary driver of the general circulation of the atmosphere is uneven solar heating across the Earth's surface due to variations in latitude. Solar energy heats the equator more intensely than the poles, creating temperature differences. This temperature gradient generates atmospheric pressure variations, initiating large-scale convection currents. These currents drive the global circulation patterns, including formation of Hadley cells, Ferrel cells, and polar cells, which in turn influence wind patterns, precipitation zones, and weather systems across the planet. 22. What is the name of the wind belt located between the equator and 30 degrees latitude and in both hemispheres? The options are A. Westerlies, B. Trade winds, C. Polar easterlies, D. Jet stream. The correct option is B. Trade winds. The wind belt located between the equator and 30 degrees latitude in both hemispheres is called the trade winds. These are consistent easterly winds that blow towards the equator from the subtropical high pressure belts. The Coriolis effect deflects these winds to the west, resulting in the northeast trade winds in the northern hemisphere and southeast trade wind in the southern hemisphere. The trade winds are crucial for maritime navigation historically and influence climate and weather patterns in tropical regions globally. Which of the following is not a cell at atmospheric circulation? The options are A. Convective cells, B. Ferrel cells, C. Hadley cells, D. Polar cells. The correct option is A. Convective cells. Atmospheric cells refer to large-scale patterns of air circulation in the Earth's atmosphere driven by solar heating and planet's rotation. The three main atmospheric cells are Hadley cells, Ferrel cells, and polar cells. 24. Which atmospheric circulation cell is found at the poles? The options are A. Hadley cell, B. Polar cell, C. Trade winds, D. Ferrel cell. The correct option is B. Polar cell. Despite being cooler and drier than equatorial air, air masses around the 60th parallel retain enough warmth and moisture for convection, driving a thermal cycle. Rising to the tropopause around 8 km altitude, the air moves poleward, its upper layers deflecting eastward. Upon reaching polar regions, the air cools through radiative heat loss, becoming denser and descending to form a cold, dry, high pressure zone. At the surface, this air returns towards the 60th parallel, completing the polar circulation cell. Which circulation cell is primarily responsible for transporting heat from the equator towards the poles? The options are A. Hadley cell, B. Ferrel cell, C. Polar cell, D. All the above. The correct option is A. Hadley cell. The circulation cell primarily responsible for transporting heat from the equator towards the poles is the Hadley cell. These cells form near the equator due to intense solar heating, causing warm air to rise. As the air moves poleward at high altitudes, it eventually descends around 30 degree latitude in both hemispheres. This descending air returns towards the equator near the surface, creating the trade wind. Hadley cells play a crucial role in distributing heat and moisture globally, influencing tropical climates and contributing to the Earth's overall climate system. 26. What is the main reason for the development of monsoon winds? A. The Coriolis effect. B. The Earth's rotation. C. Seasonal changes in temperature between land and sea. D. High altitude jet streams. The correct option is C. Seasonal changes in temperature between land and sea. The main reason for the development of monsoon winds is the differential heating between land and sea surfaces during the different seasons. In summer, land surfaces heat up faster than oceans, creating a low pressure area over the land. This draws in the moist air from the ocean, resulting in wet monsoon winds that bring heavy rainfall. In winter, the situation reverses as the land cools more rapidly than ocean, creating a high pressure area over land and causing dry monsoon winds to blow from land to sea. 27. How does the general circulation contribute to the development of deserts? The options are A. By increasing humidity levels, by creating high pressure zones with descending air, by causing constant rainfall, by lowering temperatures. The correct option is B. By creating high pressure zones with descending air. The general circulation of the atmosphere contributes to the development of deserts primarily through the descending limbs of the Hadley cells and Ferrel cells. Near 30 degrees latitude in both hemispheres, where dry air descends, it warms adiabatically and creates high pressure zones. These descending air suppresses cloud formation and precipitation, leading to arid conditions characteristics of the desert regions like the Sahara and Arabian Desert. The combination of high pressure and descending air inhibits moisture from reaching these areas, perpetuating desert climates globally. 28. What happens to the air pressure over the land during the day to create a sea breeze? The options are A. It decreases, B. It increases, C. It remains constant, D. It fluctuates rapidly. The correct option is A. It decreases. During the day, the land heats up faster than the adjacent ocean, causing the air over the land to become warmer and less dense. This warm air rises, creating a low pressure area over the land. Meanwhile, the cooler, denser air over the ocean creates a relatively high pressure zone. The pressure difference causes the cooler air from the ocean to move towards the land, resulting in a sea breeze. This onshore flow of cooler air helps moderate coastal temperatures during the day. 29. What is the term for the boundary where the sea breeze meets the warmer air over the land? The options are A. Breeze front, B. Convergence zone, C. Conjunction line, D. Thermocline. The correct option A. Breeze front. The term for the boundary where the sea breeze meets the warmer air over the land is the sea breeze front. This front forms as the cooler, denser air from the sea advances inland, lifting the warmer, less dense air over the land. The sea breeze front is often marked by a line of clouds and can lead to increased humidity and potential thunderstorms as the rising warm air cools and condenses. This phenomenon is most noticeable during the afternoon when the temperature contrasts are greatest. 30. Which wind belt is characterized by high pressure systems at approximately 30 degrees latitude? The options are A. Trade winds, B. Subtropical high pressure belt, C. Westerlies, D. Polar easterlies. The correct option B. Subtropical high pressure belt. The wind belt characterized by high pressure systems at approximately 30 degrees latitude is known as the subtropical high pressure belt. This region is dominated by the descending air of the Hadley cells, creating areas of high atmospheric pressure. The subtropical highs lead to the formation of the trade winds, which blow towards the equator, and the westerlies, which blow towards higher latitudes. These high pressure systems contribute to the arid conditions found in many of the world's deserts located at these latitudes.